Welcome to the deep dive. Today we're really digging into, well, the often hyped up world of large language models for coding. We all see the headlines, right? The flashy announcements. But I think for a working developer, the real question, the critical one, it always boils down to something like, which systems actually write code that runs? And, which ones just write code that looks like it runs?
That's exactly it. That's the core challenge, isn't it? I mean, these glossy claims about LLMs, they often just fall apart the second that output lands in an editor, especially when it has to meet like a real world deadline. Developers don't need another slogan. They need practical, actionable answers.
And that's precisely our mission today. Think of this as a kind of field guide,
Yeah.
to finding the genuinely best LLM for coding in 2025. And we're building it not from marketing stuff, but from two really insightful and complementary sources of truth. We're talking about two key evaluation families that are really setting the pace here.
That's right. The first one is the International Olympiad in Informatics benchmark, the IOI benchmark. Just imagine a set of really ruthless algorithmic puzzles, plus an automated grader that takes absolutely zero excuses. It's a pure pressure test.
Ruthless sounds about right for competitive programming.
It really is. It tests a model's deep reasoning, tackling complex stuff like graphs, dynamic programming, combinatorics, you name it. And the Val's AI team, the ones who built this, they didn't just ask models to generate code. They set up this whole agent harness.
An agent harness, what does that involve?
Well, it's got a modern C++20 toolchain, a submission server that actually mirrors the real contest grader. So what that means is they push the models beyond just simple code generation. The model has to reason through problems, plan its steps out, and even repair its own mistakes. Just like a human developer debugging their own code, right? It really rewards planning and, iterative repair, not just getting lucky on the first try.
Wow, okay. That sounds incredibly rigorous, almost like a nonstop coding interview from hell. But I guess the question is, how representative is that kind of extreme algorithmic pressure test for, the average developer's day-to-day coding?
That's a really excellent question, and it brings us straight to our second key benchmark, LiveCodeBench. This one's described as more of a rolling, never sleepy suite. It keeps shuffling in fresh problems from platforms developers actually use LeetCode, AtCoder, Codeforces, and then it verifies the functional correctness using hidden tests. It's much more geared towards the daily engineering cadence.
Ah, okay. So one's the high-stakes puzzle solving, the other's more like the practical day-in, day-out coding grind.
Precisely, yeah. The design of LiveCodeBench, it specifically fights against data contamination by constantly adding new problems. And it keeps the focus squarely on, does this code actually work, functional correctness. It also includes richer scenarios, things like predicting test output, self-repairing code, giving a much broader signal than just, single-pass code generation. It shows how a model handles the reality of iterative work.
Okay, so we have these two powerful benchmarks. One digging deep into algorithmic puzzles, the IOI one. The other, LiveCodeBench, mimicking the daily practical stuff. And this is where it gets really interesting, right? Because a super useful split emerges when you look at how different models perform across both.
Exactly. What's truly fascinating here is that on that algorithmic gauntlet, the IOI benchmark Grok 4 actually pulls ahead. It shows its strength in that deep multi-step reasoning. But then on the practical Python feed, that's LiveCodeBench, GPT-5 Mini just steals the show. It excels at those rapid-fire, real-world type coding tasks.
Right. So at first glance, that might sound contradictory. Yeah, one wins here, the other wins over there. Are they just good at different things, or is there something more kind of fundamental going on?
It's definitely not a contradiction. It's actually, well, it's like a map. This split tells you pretty much exactly what each lab optimized for. Grok 4 is clearly tuned for those long chains of reasoning, makes it strong on IOI. GPT-5 Mini, on the other hand, it seems fine-tuned for fast, clean, functionally correct snippets. That's why it thrives on LiveCodeBench. And understanding this distinction, that's absolutely key to finding the best model or models for your team and your specific workflow.
That is a fascinating map. It really shifts the perspective. So if these models have such distinct specialties, it sounds like we're not just looking for the single best model anymore. Maybe it's more about the right model for a particular job. Does that mean we need a whole new strategy for how we, integrate them into our workflow?
Precisely. Yeah, the whole idea of a single king model is really giving way to a much more practical reality in 2025. The best LLM for coding. It really involves a small, well-orchestrated crew, a team that works well together in a sort of tiered workflow. Think of it like building your ultimate coding team.
Okay, let's make that concrete. Let's connect this map to, say, your daily life as a developer. You wake up, you've got your backlog, some small fixes, maybe a tricky feature, maybe a big refactor. How do these different LLM personalities become your ultimate coding team in practice?
Okay, well, for those daily snippets, right, the rapid-fire tests, quick utility functions, you'll probably want to reach for GPT-5 Mini first. It's incredibly fast responses, and those high pass rates on the fresh LiveCodeBench problems, they just mean it keeps your dev loop really tight, really efficient. It feels almost instant for common tasks.
Okay, fast and reliable for the everyday stuff? Makes sense.
Yeah.
What about harder problems?
Right. Then, when a ticket really turns into a puzzle, like a stubborn algorithmic challenge that needs deep thought, multiple steps, that's when you call in Grok 4. It leads on those IOI-style problems because it tolerates longer chains of thought, more retries. It pushes further than other models before giving up on those really sharp-edged, complex problems. Think of it as your designated whiteboarding partner for the really complex code.
Got it. The heavy lifter for algorithms. What about sensitive changes? Refactoring large chunks of code.
Yeah, for sensitive diffs, large refactors where the stakes are genuinely high, you should absolutely reserve Claude Opus 4.1. Its strong performance on repository-sized edits, its careful, deliberate reasoning, that's critical there. It seems specifically designed to avoid common LLM hallucinations, providing really reliable outputs. And yeah, while it definitely comes at a higher price, its value really shines when you absolutely cannot afford a mistake.
The reliable, careful one for the critical jobs.
Okay.
Are there others in the crew?
Definitely. For those moments, you need really fast iterations, maybe spinning up prototype endpoints, quickly connecting APIs, keep O3 and O4 Mini close by. They offer a fantastic balance of accuracy and speed for that kind of quick API or data glue work. Lets you prototype and test ideas with incredible agility.
The sprinters for prototyping. Nice. And anything else?
One more, yeah. For long reads like dense documentation or multimodal work, say, summarizing a complex RFC or analyzing a design doc with diagrams, Gemini 2.5 Pro earns its slot. While it might trail the very top models on like the raw code accuracy charts, its broad knowledge and reliable summarization for extensive technical texts, that makes it incredibly valuable for the research and planning phases.
So it's really about using the right tool for the job, assembling this specialist team, which raises an important point for you, the listener. We've talked about benchmarks, leaderboards, but as every seasoned developer knows, the only result that really matters for your users and for your team's productivity, it truly comes from testing on your own code.
That's absolutely it. Couldn't agree more. Benchmarks are like a compass, right? They point you in the right direction, but they are definitely not the destination itself. You will learn more in a single day testing these models on your own code base than you would in a week just looking at screenshots or public leaderboards. Seriously.
So here's the challenge then. Go beyond the public data. Put these insights into practice. Run a simple experiment in your own environment. Maybe curate, say, 10 to 20 tasks from your actual backlog. Make sure it's a mix. Include something simple like parsing a log file, maybe a tricky dynamic programming problem you've been stuck on, a multi-file refactor. And definitely include tasks that rely on third-party SDKs unique to your setup. Write hitting tests, just like LiveCodeBench does, so you can objectively check correctness.
Yeah, and for those more agentic trials where the model has to think, plan, self-correct, borrow those ideas from the IOI harness setup, give your model a compiler, maybe a submission budget, really stress test its reasoning capabilities.
Then tips. And
Yeah.
practically speaking,
Keep your prompts short and stable. Try to minimize the variables, right? Make sure you track key metrics. Pass at 1, that's the percent solved correctly on the first try. No human help. Also, wall clock latency. How quick is it really? From query to full response. And of course, estimated token cost, because that hits your budget directly. And here's a crucial tip. Don't rush to commit to just one provider. Build a small switch, maybe an abstraction layer, to route requests to different backend models. Collect your own results carefully.
we really believe that as you run these tests on your own real-world code base, you'll likely see the same kind of pattern emerge that the public data is revealing. You know, a fast, efficient model like GPT-5 Mini probably covering the bulk of your daily work, handling routine tasks quickly.
Exactly. And then a heavyweight, deep reasoning model like Grok 4 unlocking those stubborn, complex algorithmic puzzles that have been sitting there in the backlog. And a careful, reliable model like Claude Opus 4.1 protecting your sensitive edits, your large refactors, minimizing that risk.
So your best LLM for coding in 2025, it's going to look less like a single all-conquering solo act and much more like a well-coordinated, highly effective team effort. Go test it out.